Good day, dear learners. Today we shall be learning how to determine the distance between 2 points along the parallel of latitude. So the topic is longitude and latitude, and our focus is on determination of distance between 2 points along the parallel of latitude. We have this question here in which 2 points lie on the same latitude but different longitudes. So we are asked to find their distance apart along the parallel of latitude. So the very first thing is that we have to sketch the diagram of the Earth's surface so that we can have clear understanding of this. So we'll move on with this. Here we have the polar axis. So we have our north, the east, the south, and the west. So they lie on the same latitude, and the latitude is 25 degrees south. So latitude 25 degrees south, somewhere like this. 25 degree south, and the first point, let's call that point A, which lies on the longitude 10 degree east. So the longitude 10 degree east is something here. So the point where the latitude and the longitude intersect, that is the point A. Let's call this point A. Then the next one, the second point here, that's 75 degree east. So 75 degree east is going to be this. So this point is our 10 degree east. This is 75 degree east. So this is our point B. They lie on this parallel of latitude. So if we were to complete the circle that produces this parallel of latitude, the circle will become something like this. That's a small circle now. It's a small circle. This is the center of the Earth, which is the center of every great circle, but this is a small circle here. So we can pick its center here. That means from the center of this small circle to any of these points A or B, the distance there is the radius for that small circle, which is small letter r. Is represented with small letter r. Is not the same thing as the radius of the Earth. So from here to here is the same thing as from here to here, which is small letter r. That's the radius of this small circle. So if I redraw this small circle, it looks like something like this. So if this is the center, let's say this is what it has with the polar axis, and this one is a point A, which is 10 degrees from here, and we have point B, which is 75 degrees from this. So now our interest is to calculate the distance between this A and B along this path. That's the arc. So to be able to determine this distance, we will need the angular difference between point A and B. And that angular difference is equals to the difference between 75 and 10 degree. That's 75 degree minus 10 degree. and that gives us 65 degree. So that's our theta. That's the angular difference between these 2 points. That's our theta. So quick one, let's learn this. If 2 points are on the same latitude or they are on the same longitude, to determine the angular difference between them, it follows this logic. If the 2 points are not on the same axis, let's say for example when they are on the same longitude, so they are going to have different latitude. If the latitude is north and the other one is south, we are going to add the angles. But if it is south we subtract. If it is north we subtract. The same thing if it's on the same latitude but different longitude. If it is west and east, we add. If it is east and east, we subtract. If it is west and west, we subtract them. Let's take note of that. So look at this. We have the 10 degree east and 75 degree east. So we are going to subtract them. And that's what we have done here. And we have been able to get our angular difference. So how do we then determine the radius of this? This is the radius of small circle. The radius of small circle has its own formula, which is small r is equals to the radius of the earth cos the angle of the latitude. In this our question, the angle of our latitude, that's alpha, is equals to 25 degree. So our r then is equals to 6,400 multiplied by cos 25 degree, which gives us 6,400 multiplied by 0.9063. That's the value of cos 25 degree, and our r will then be 5800.32. That's our radius for the small circle. So now our interest is the distance between the point A and B. If you look at this carefully, this is an arc. So we are using a formula length of arc for the distance between A and B. And recall that that's distance along the parallel of latitude between 2 points A and B is equals to theta over 360 degree multiplied by 2 pi the radius of that small circle, which we have gotten here to be 5,800.32 kilometers. So we then need to substitute the values that we have here. Theta is 65 degree over 360 degree multiplied by 2 multiplied by the pi, which is given to us as 3.142, then multiplied by the radius of the small circle that we have calculated to be 5800.32. So following this, depending on how well we can do our simplification, we can say 2 goes here 1, 2 goes here 180. Then out of 180 you can say 5 goes in 180, that will give us 36. 5 goes here, that will give us 13. So you can say we have 13 multiplied by 3.142 multiplied by 5800.32, everything over 36. 36 here. Okay, let me rewrite that. Everything over 36, 36. So here we can use our calculator to multiply all the numerator, which is going to give us 13 times 3.142 times 5800.32. That gives us 236,919.87 divided by 36, and our answer here will then be 6581.10 kilometer. So we can then say, therefore, the distance along the parallel of latitude of these 2 points is approximately 6581 kilometers. So we have been able to successfully determine the distance apart measured along the parallel of latitude for the given 2 points on the Earth's surface. If you enjoyed this video, don't forget to click on the like button. Also subscribe to our channel for more educative videos. Till we see you again, subscribe to Demi Academy.